Assalamualaikum warahmatullahi wabarakatuh. So this video I will explain another example for absolute values in inequality. So example 9, solve the modulus of 2x minus 1 greater than x plus 3. So this question we assume that the value of x plus 3 is positive value. Okay, so by using properties number 3, the absolute values of a greater than b is a greater than b or a is less than negative b. So 2x minus 1 greater than x plus 3 or is union. Okay, 2x minus 1 less than negative x plus 3. So you simplify lah. Okay, and then this one you divide with positive number because you want to get x, so don't no need to reverse the inequality sign. So union or is union. If less than the connection is and here and is intersection, but this one is or union. So by line graph, draw for x greater than 4, for x greater than 4. So this is x greater than 4. For x less than negative 2 over 3. For x less than negative 2 over 3. Alright, this one. So in interval notation, okay, the answer is between negative infinity to negative 2 over 3. Okay, and then at negative 2 over 3 is open interval. Means that does not include the endpoint. Union, because we have two shaded areas, so you must put union here. 4 to infinity, open interval. Both are open interval. Okay, next question. Next is the question consists of modulus and also rational. So solve the inequality for question which is include absolute values. Okay, we must make sure that one side is absolute values only. So we must have absolute values only, and then the other side is another number. Okay, this one you can use properties modulus of a less than. If it is less than, then a is between negative b. Okay, when it is between, so you must follow the properties first. Okay, x plus 3 over x minus 1 is between negative 1, negative 5 and 5. Okay, so you must write these properties first, and before you solve, you know that the denominator is not equal 1, because when x is equal 1, the denominator is equal to 0. So we must exclude answer x is equal to 1. Okay, and then when we want to solve separately, so x plus 3 over x minus 1 is greater than negative 5 and okay, because this one is less than, kan, ikut follow the properties. Okay, and x plus 3 over x minus 1 less than 5. So solve separately. So we know that NE is the intersection. Okay, so solve. Okay, please do not cross multiply because we are not sure the value of x minus 1 here. So this is rational inequality. So you must bring all term to one side and then find the single fraction, right? It is greater than 0. Okay, the right hand side also, please don't cross multiply. This is a common mistake. If you cross multiply, you must bring all term to one side. Okay, simplify, then you get rational, which is less than 0. So this is single fraction on the left hand side. So we must remember that x is not equal to 1. X is not equal to 1. Okay. Okay, and then this is rational. So we have two factors here, which is 6x minus 2 over 1. Okay. we have two factors here, 6x minus 2 over x minus 1. Okay, so each of the factor, you find the zeros. Okay, so zeros are 1 over 3 and 1. Okay, so two zeros will divide the number line into two parts. Right, so set up the number line, set up the sign table. Okay, this is divide kan, so choose test point, test value from the interval. So since the question is we want the value of x is less than only, so we don't want it is equal to. Okay, so we exclude answer 1 over 3 because 1 over 3 when x is equal 1 over 3, so 6 times 1 over 3 minus 2, this is 0, 0 over something is equal to 0. So 0 greater than 0 is false statement. So that's why we exclude answer 1 over 3. 1 exclude lah. Okay, so set up the sign table. So for this part, the first part, we want the values of x which expression give greater than 0. So negative infinity 1 over 3, 1 infinity. Okay, so this is the first table. Okay, the second table, we also have to factor here. Find the zeros for each factor. Okay, these zeros divided the number line into three parts. Alright, and then it's exclude 1 because 1 when x is equal 1, it will become something over 0, so undefined. Exclude also 2 because we only want less than. Okay, if we want less than or greater to 0, then we include answer 2 because negative 4 times 2 is negative 8 plus 8 is 0. 0 over something is 0. 0 less than 0 is false statement. Okay, so now draw number line. So what are the numbers? 1 over 3, 1, 1, 2. So numbers are 1, 1 over 3, 2. So start from here. X is less than 1 over 3. Less than does not include 1 over 3. Okay, and then 1 infinity. Okay, greater than 1. So this is the number line for table 1. Okay, now look at table 2. Table 2 above, right? So x less than 1, less than 1. Okay, and then greater than 2. So this is greater than 2. And then look at the question. We want the question is less than. Less than is n. Okay, when we split it, we use n. So n here, n is overlap. Okay, overlap. So where is the overlap area? So the overlap area, so answer is less than 1 over 3 and also 2 infinity. So we have to share the area. So union lah. Okay. So this is method 1. We call this method as by definition, using definition of the absolute value. So if the question is greater than 5, we solve separately, then this is all. Okay, or, so when it is all means that all answer lah. Okay, all lah. Sini. All real number except 1 if the question is greater than 5. Okay.